Morning, Doctor. This is Group SWML16 presenting an AI-powered building instance segmentation for urban imagery, for urban planning using aerial imagery. These are members, Nimbaba Cesar Davis, Moses Mpiriwe, Alvin Kais, Kenneth Maiga, and those are their registration details. Moving on, we can see that the problem that our solution is trying to solve is the lack of accurate, scalable, and automated methods for identifying and outlining individual buildings in aerial imagery. This leads to poor mapping, inefficient urban planning, and slow disaster response due to limited access to critical infrastructure data. Generally, our solution is trying to transform raw imagery into usable infrastructure data. Who is affected and why does our solution matter? We can see that governments, including city authorities, land agencies, planning ministries, disaster response organizations are all affected. How? We can see that they lack no accurate building data. They lack accurate building data, which leads to poor planning decisions. Rescue teams are facing a problem like they don't know the exact building location, making it hard to assess damage quickly, leading to slower rescue operations. Here our solution comes in. We can see that mapping and navigation platforms are also affected. These facing complete and inaccurate building data or even missing roads or building relationships, leading to poor navigation accuracy and missing locations. Why our solution matters, we can see that for governments, mapping platforms, even disaster and rescue teams, we are trying to give them a solution. Our system will automatically extract accurate building footprints from aerial imagery, providing live and up-to-date data. Our system will also enable faster identification and analysis of buildings, allowing quicker disaster response and better planning decisions. Moving on, we can see that how our AI-powered solution will change everything. Our AI-powered solution will solve most of the problems by automating what was previously slow, manual, and inaccurate. That is turning raw aerial images into usable and real-time building data. It will scan images, detect every building in the images, separate them individually, and produce exact digital outlines or footprints in the images, from the images. The technology and architecture of our solution, we can see that our system is AI powered. It's following a pipeline for transforming the data. It's built on TensorFlow for model training. Aerial images are processed and fed into deep neural networks that identify and separate individual building or even in dense urban areas. That's how our system works. The output generates accurate building footprints. The output is so crucial. So it generates accurate building footprints from mappings and spatial analysis. How we are going to leverage our solution into a successful business model. It will sustain itself through a B2B, that's a business to business, that as a service model. Governments, urban planning agencies, humanitarian organizations will pay for updated building data sets and analytics dashboard. Tech companies will contribute revenue through licensing or API usage fees. Other adopters are state councils, disaster response agencies, mapping startups, additional revenue streams through subscription fees, or even enterprise API integration for real-time image processing. That's how we are going to make our future plans include a shift from static satellite or drone imagery to real-time video streams and temperature change detection for higher accuracy and faster updates. We shall scale through cloud-based distributed processing, image processing of image data, expanding region by region coverage, and automating model retraining with new data streams. That's how we are going to scale our solution, and we make sure it works. This is our prototype. We can see that we input images and we expect the output. In conclusion, this solution is going to turn raw images into real-time actionable geospatial data. As it expands across cities, it becomes more accurate, faster, and autonomous through a continuous AI learning. Thank you, Doctor. Uh, that was our presentation as Group SW ML16. That's all.